Yeah, we've got Richard VK2ARH, who has very graciously put all of our kits together and ordered everything and done a whole heap of work. So tonight it's going to be basically he's going to take us through the build, some tips and tricks, what we need to know before we actually build, which I think will probably get underway next week, unless you're really keen and want to start it tonight. So I'll hand over to you, Richard.
Thanks, Hayden. I'll just turn my camera off to make sure I get the maximum amount of bandwidth down to you to work its way through. Look, thanks for the opportunity to talk to everyone and also to share the ADX project with you. My plan for the next, I'm not quite sure how long the presentation will run, but my plan is to basically talk about the Cowtown Build-a-thon program, which really kicked this whole thing off. And you'll hear reference to the Cowtown project several times, probably as you look through some of the material, but I just want to put that into context. But then we'll get into the main event this evening, which is just talking about the ADX and the project that you guys are about to embark upon. So let's kick it off. Look, the Cowtown Build-a-thon event was an event that I should say by way of background. I'm an Australian, obviously, by accent. I'm actually a Tasmanian, grew up down in Tasmania, but worked on the mainland and overseas for quite a number of years before retiring last year and coming back to Australia. Whilst I was in the US, and I was there for a total of about six and a half years, I was a very active member in the last 5 years or so with the Cowtown Amateur Radio Club in Fort Worth, Texas. And we set about doing a very similar thing to what you guys are doing, making sure that our meetings weren't just about business meetings, but we actually did something. And we set about creating our Build-a-thon program with the idea of promoting the hobby, generating interest, etc. But we're also targeting the new hams to try and get them involved in expanding their knowledge, skills, and practical competencies. In the US, the technician class license is a fairly easy license to study for and obtain. And a lot of people come into the hobby without a lot of practical knowledge and experience, and this was a great way to share that with them. It also had a lot of side benefits insofar as it built our membership participation, and we certainly had we increased our membership by about 25% as a result of this activity. But more importantly, the existing members were turning up far more frequently at meetings and putting in appearances, which was great for the club and great for the hobby. But the reality was, it was all about having some fun. Now, when we chose the projects for the Build-a-thon, we were really looking for something that it first of all had to be inexpensive. We wanted it to use through-hole devices in order to be able to have it built by newcomers, if you will, to building kits and electronic components. And then we really wanted to deliver a learning experience through it. But we also wanted people to have a practical product that they could actually use at the end of the program and actually use it in their shack, take it out in the field, and the ADX certainly fits that bill. It also provided people with the confidence that once they built one of these things, to perhaps stretch their skills a little bit more and learn more and build something bigger and better. But a lot of fun on the way through. If you've got nothing to do in an evening, you want to see how that program went, I put this video together here for primarily for Barb, the designer of the product, to show him what we've done, but also to support other clubs and perhaps gives them an idea as to how to go about that. And we produced a lot of material to enable people to do group buys and so forth for their clubs to be able to do that. Anyway, look, that's by way of background to what it was. And just quickly positioning it here, we actually built the ADX of one of 3 projects during 2023. The first project we did was the end-fed half-wave antenna. We then moved on to the ADX, and then we moved on to QRP antenna tuning unit. All of them were complementary. They could use them all as part of their gear that they actually built during the year. And so it slotted in quite nicely into that space. So let's talk about the ADX and a fair bit of stuff to go through here. And if possible, perhaps try and hold questions to the end, maybe write them down. If something is burningly urgent, please don't hesitate to interrupt. But we'll see how we go, because I think you find some of the questions you may well ask may well get covered as we work through the presentation. Now, the ADX, which stands for Arduino Digital Transceiver, it's an easy to build little kit. It uses only through-hole components, although the low-pass filters can use surface mount capacitors, and the ones that we have in the Reast kit certainly do that. I've got several slides talking about the low-pass filters later on, but we'll go into more detail at that stage. Typically, you can get up to 5 watts. Most people usually see between 3 and 4 watts of output using 3 BS170s for the final phase. A good bit of tuning, you can get it up to 5 watts, and that's an art form in itself. Primarily supports the single tone frequency shift keying, and is programmed to operate on Whisper, JS8 Call, FT4 and FT8 modes. We also, in the ADX was originally a 4-band transceiver, but we modified the firmware and increased the number of low-pass filters so that it can actually operate all across the 7 bands that we've got shown there. You can program it otherwise, but that's the way the kit and the firmware is currently delivered at this point in time. Just need to check one thing here. My speaker's notes have disappeared. They're back. And the individual frequencies for each of the modes are actually hard coded in to the firmware. You can obviously go and change that if you wish to use another, want to try and experiment and do something different with it, but they're shown on that slide there. It only supports digital modes that with single tone frequency shift keying. It doesn't support MSK144 or CW because there's no click reducing RF envelope shaping in the design. And it's also not suitable for phase shifting modes such as PSK31 or modes that involve multiple concurrent tones such as you might find in WinLink. But if it's single tone frequency shift keying digital, it'll be fine. Now, the ADX comes with in a set of boards to form what I call a sandwich to enable mounting, and it really does provide quite a neat self-contained package. I think both the manual and some of the updates that I sent out also pointed to a 3D box that you can put it in to house it in if you wish to do that. I have one of those boxes. I actually don't put my ADX into that box. I like to leave it open because the final's sitting over here. A lot of airflow through there, which helps cool them if should that be required. But if you're putting it into some other form of enclosure is your thing, please go right ahead to do it. Obviously, having made sure that you're running your finals efficiently. Now, this kit was put together via a group buy. Initially, when we did it in the Cowtown group, it was supplied with a single 10-meter band low-pass filter that was primarily aimed at the technician class members to get them going on the 10-meter band. But virtually everybody ended up purchasing whole sets of filters. So this is now the 3rd time I've run this project for a radio club. We did it here in Sydney last year. We now have a 7-band filter set, so it just significantly simplifies the logistics of getting these low-pass filters together, but it also gives everybody the full option of using whichever band they choose to. And the other thing about it is that the hardware components that are used in the kit are readily available. They're inexpensive and fairly easy to replace should you need to do so. Low cost, they're about $35 to pull together as a group buy if you do appropriate bulk buying and share your freight amongst multiple components. And the kit includes absolutely everything you need to get a fully functional ADX transceiver up and running. Now, this is the guy, Barb. Barbaros Asogolu. I'm not sure how I pronounce his surname, but I've always referred to him as Barb. Fantastic guy. WB2CBA, lives in New Jersey in the US, originally from Turkey. He designed the ADX using direct frequency shift keying, and you may know Barb is fairly active in a lot of the discussion groups, and he was one of the designers of the micro SDX QRP Transceiver. He's a civil engineer by trade, but a radio and microprocessor hobbyist at night. So he's put a lot of work into it. A great vote of thanks to Barb for bringing this together for everybody. Now, I'm going to assume that most people in the room know and understand about digital modes, but some people have found don't quite understand what direct frequency shift keying signal generation is. And as this is key to what the ADX does and how it works, I've just grabbed a few quick slides of background, stolen them from Hans Summers from QRP Labs, who presented. These are some of the slides that he used at a seminar in the US, I think it was about 18 months ago now, where he spoke about the QDX, which is one of his things. Now, most people probably understand what digital mode is. Most simplest form of digital code would be Morse code. It's ones and zeros, key down or key up. But usually, whichever method is being used to send a digital signal, some form of computer generally encodes and decodes them. And there are various modulation types, on and off keying, such as CW, frequency shift keying, as we would find in FT8, Whisper, or RTTY. Phase shift keying is pretty much used in wireless LANs, RFID, and Bluetooth. And we also get spectrum digital techniques when we're trying to avoid noise and jamming, also perhaps used on satellite downlinks. We use digital modes and can use digital modes for a range of transmissions, text, chat, QSOs between two computers, video, images, pictures and images, I should say, propagation testing with Whisper, and even used in balloon telemetry. Some of the features of most digital transmissions, they're often narrow band, but that does improve the signal to noise ratio at the expense of speed. Often seen as low power, weak signal modes, although not necessarily the case. The system may or may not include error detection, but it's a method which is ideally suited to QRP. Most setups typically use a computer to generate and encode the audio, and an SSB rig to receive and transmit the audio. That's traditionally the way it's been done. Most of that software most of those computers run some of the popular software, WSJTX, JS8 Call, FLDigi, but they all usually send and receive audio tones to and from a sound card. Now, if we look at the ways that you might typically generate a CW signal, the simplest way would be to have a crystal-controlled oscillator, which is fed through to an amplifier, and you simply then have a crystal-controlled transmission, which is switched on and off to generate your CW. Another way that that's done is to take a 700 hertz tone, or whatever tone you wish to your CW to sound at, superimpose that onto a sideband signal, and transmit that tone in amongst the signal, which is then decoded. Of course, that becomes quite inefficient from a radio perspective, because you have a carrier that needs suppressing an unwanted sideband that you don't want to get through there. So the same applies with digital. When you want to send that, you could send the digital tone through an SSB transmitter, or you can generate it directly, clean and simply. And this is the system which is known as direct frequency shift keying. So in fact, if we wanted to transmit at a base frequency here of 14074 for an FT8, and you wanted to have a 1750 hertz audio tone on it, you could feed that into a single sideband transmitter and actually have it transmit in the middle of the sideband and decode it accordingly. Or you can actually adjust the frequency of the tone that's being transmitted, or the frequency of the signal that's being transmitted, and actually make it at the frequency that you require. And you can see that here. This is on FT8, where you've got a 1750 hertz signal sitting on top of the 14074. By the way, as you probably may well have seen in some of the things I've put together, when the IC7300 is on upper sideband digital, the band scope is actually centered in the middle of the upper sideband. So the 0 point down here for 17.074 sits down here, and the 1750 hertz carrier will sit up around this particular location here. But this is a much simpler way of generating the audio tone for digital use. Direct frequency shift keying, in other words, we directly generate the signal, and then we vary that signal directly in accordance with the changing requirement for the digital code that's being sent. Now, I said I did grab these slides from Hans, and the QRP Labs was perhaps one of the first commercial organizations to really take advantage of that and make use of it. Here is the QDX, their digital transmitter. I know you were considering looking at that, I think, for possibility for one of your projects. This is mine. This is the one that I built. Just to give you an idea, if you're not familiar with them, they're about $165, including the housing and freight by the time you get them to Australia. You can get them fully built and tested for another few extra dollars. They come in 2 variants. It's a great receiver. It really is a very sharp receiver there. It uses a single audio cable for CAT and audio control, but you do have to choose whether you want the low band or the high band option. My own experience has found that you do need to make sure you've got good isolation from common mode currents, otherwise the transceiver starts dropping off, if you will. But 3 times the cost of the ADX, but an absolutely fantastic little radio. The next step that QRP Labs used was the QMX. That's also another direct frequency shift keying radio. Again, this is my QMX that I built. A lot more expensive, but far more capable radio in terms of what it has. I must admit that this is not a build for the faint-hearted. There are 3 boards there: a base board, the display board, and a power supplies. It's a very complex, compact build, and a lot of people struggle to actually get them to build and work. And also, a lot of people have them built first time, as I was able to, and they work beautifully. Very exciting development, because this has now been Hans has released a single sideband for voice in beta, so that long-awaited upgrade is certainly coming forward. But again, a very popular radio that uses audio, the direct frequency shift keying. Now, to overcome some of the problems with the QMX, Hans went and developed the QMX Plus. Pricing is a little bit more expensive here. With any of these builds at the moment, I checked this afternoon, you're looking at almost 4 months waiting list. If you order it, you've got to wait 4 months for it to be built before it gets sent to you. But this was designed specifically to overcome the challenges of the small footprint of the QMX. And a lot of people were having difficulty building that. This spreads it out a little bit, makes it a little bit easier, but it does come with 11 bands. It's a great radio, but certainly not a beginner's radio kit. So that brings us to the ADX. Let me say first off for a moment, this is nothing by comparison to the QDX and the QMX in terms of its performance. This is a simple radio designed for a club project for people to build and have some fun, inexpensive. But I just wanted to give you may have seen some of the commercial availability or the variants of that. I wanted to position them for you so that you knew what was what. So here we have the Cowtown kit, as we're calling it. Was used by the Cowtown group, the Manly-Warringah Radio Society, and now you guys in the build-a-thon. We managed to put that together for a group by around 55 Australian dollars, including the 7 low-pass filter kit. Now, commercially, you can buy the 4-band equivalent of that from Jason Kits on Tindy. They're about $85, landed here in Australia with 1 low-pass filter. You can buy additional low-pass filters for about $8 a piece. It's fully assembled, but by the time you've got a few low-pass filters in there, it's almost double the price of what you can do here. And you don't have the fun of building it and putting it together. Now, Adam Wrong in CR Kits developed the ADX-S, which is actually a super heterodyne version. The ADX uses a direct conversion receiver in the CD203 chip. The ADX-S uses one of the other mixers in the CD203 to use a super heterodyne receiver, because that overcomes a lot of the broadcast interference that some people have in various areas. That was a design or a suggestion that was brought up by a Japanese amateur, which Adam incorporated into that kit. Now, in the Cowtown group, we were originally going to build the super het version, and we developed the modifications that Adam incorporated into his design. It's a fairly simple process to change that on the ADX. You can see the mods here. There's a ceramic filter, an additional capacitor here, and a couple of tracks need to be broken and jumped. So I do have the ability for people to do that if they want to, but I'll talk to that on the next slide. Now, Barb, being a bit of an avid designer, also developed an ADX Uno, which is effectively a hat that sits over the top of the Uno, but he subsequently abandoned that, and I'll talk to why in a moment. And then Scott Baker, sitting over there, I think Scott's in Seattle in the US, decided to take the ADX and miniaturize it and put it on an SMD type board. They're about, I've got one sitting here in front of me. I'll show you when we turn the camera back on at the end if you're interested. They're about a third of the size of the ADX. But you know, they run about $107. You can still buy, by the way, Scott's, these are sold through Jason Kits in Tindy. Barb then, of course, not to be outdone, went to try to miniaturize it and use the ADX Pocket. Scott then continued to, and then went on to develop the DX Uno, which is, this is a QRP transceiver. It's good for 4 bands and makes a fantastic whisper transceiver. I've got one sitting here in front of me. It's pre-built. You only have to solder on the connector here, the SMA connector, but only 300 milliwatts. Great as a whisper beacon. I haven't had a lot of success using it for FTAs and the like, but it certainly has all the capabilities that the ADX has, except you don't have to change low-pass filters. It's all built in on that particular board that you see there. The ADX-S has been improved to a version 2. They've added some receiver mods, low-pass filter detection, reduced the number of toroids being used, and also put a transmit crystal in for greater stability of the BFO, and also as an option for a Bluetooth audio. Now, Scott went on to develop the ADX Mini 1.2, which is effectively all he did here was add a sound card, so he didn't have to use an external sound card, and also he's put cat control on the I should say the ADX comes with cat control. The cat control now also detects which low pass filter is installed. There's a fourth there's an additional resistor added here which the microprocessor reads, and it won't go into transmit if you've got the wrong low pass filter installed. And his final iteration of that was the ADX Mini 1.3, which, I'm sorry, this is the one that has the low pass filter detection. And he also replaced the interface, so you've got a little screen down here which tells you which mode, rather than relying upon the light indicators that you have. Actually, they're down here on the minis, or up here, if you will, on the ADX. Now, as I said, if you want to, at a later stage, do an ADX-S modification, if that's what appeals to you, I do have the documentation available to do that. However, what we found was that doing that introduced about a 6 dB loss into the receiver. And now I understand recent improvements to version 2 have overcome that with some workarounds, but I haven't tested or managed to compare them as yet. But if anybody, once they've built their ADX, wants to try and give the ADX-S a try, please get in contact with me. I'm only too happy to send you down the instructions, and also a ceramic filter here so that you could make that change if you wish. I personally don't use it. I built an ADX-S, and I ended up selling that before I left the US, and I just stick to and use my ADX when I'm wanting to do that. I'm sorry, that just here, this is the crystal that they put on the SI5351 to create more stability. Here's the optional Bluetooth unit that uses as well. But look, this was all about trying to give you some background so that when you do hear some of this nomenclature floated around, or you do hear people talking about other ADX type things, hopefully that's given you an indication of where they are or where they're actually positioned. Now, the ADX itself, let's just take a quick look at how it's structured and how it's put together. The power supply for it comes in through the 5.5 by 2.1 millimeter DC plug on the top here. It goes through some filtering before it's supplied to the Nano, which also uses the onboard 5 volt and 3 volt supply for other components on the board. The power supply filtering around here is associated with the receiver chip, which is the CD2003 sitting here. The real brain of the ADX is actually the Arduino Nano. that's responsible for generating the RF signal using the VFO. It looks after the user interface and the dialogue between those switches and LEDs, and also calibration of the SI5351. I said its onboard regulators are used to supply other equipment on the board, and it uses that FSK, direct frequency shift keying method, that the QRP guys and QRP labs use in their modules. The audio interface takes the tones from WSJTX or whichever software you're using, passes it through a band filter, and then presents it to the comparator input, analog digital comparator input on the nano. That comparator looks for a start and stop zero cross detection on the incoming frequency, and from that is able to determine the period of the tone that's actually coming in. It uses that, adds it to the base frequency, and then instructs the VFO to generate the tone, which is then passed out through the power amplifier and the LPS after it's been amplified through the transmit buffer, I should say, to the power amplifier, and then the LPS for outbound activity. VFO just uses the standard inexpensive SI5351, and it provides quite a good level of performance for that. The CD2003 is actually a Chinese clone of the Toshiba's TA2003GP. It's an AM/FM radio chip, but we're only using the direct conversion component of the CD2003. As I indicated before, the transmit buffer takes the output from the VFO, goes through the octal buffer, and then presents it to the power amplifiers before it gets sent out through the low pass filter on its way out. As far as the user interface is concerned, there are 5 LEDs, 4 across the top here, and the transmit LED and switches. Now, I won't go into it here, but basically there is a small video that you can, I think you've got the details for, you can look to, which shows you how to change bands and how to read the digital mode that's being transmitted. We originally started out, as I said, with 4 bands. Bands 1, 2, 3, and 4, and you could allocate which bands you wanted to in the firmware. As we built that up to a 7-band operation, you can see the descriptor here, and this is the custom-built Reast top panel, and there is bands 1, 2, 3, 4, 5, 6, and 7 on the top, and they correspond as delivered, if you will, to 40, 20, 15, and 10 meters. And then when 2 lights illuminate, it's going to correspond to the top row there, 80, 30, and 17 meters. Now, the version that we've sent, that I sent down to you, does have 1.6 on it, which supports cat control. So you can use cat control for changing frequencies and also mode. But the reality is you still have to change your bandpass filter manually. So I personally don't use cat control on the ADX. I just find it easier. I don't find manually changing the frequency or the mode of operation too arduous at all, and it's a good thing to do whilst I'm in the midst of changing the low pass filters. So when we start to look at the kits that I put together and sent down to you, here they are sitting on our kitchen table, or breakfast bar, if you will, getting assembled ready to before they're packed. I must admit I was only able to do this when my wife went out for the day, so I got a clear run at it. But basically, you have a kit that's shown here. I'm not sure whether you've handed them out or not as yet, or whether that's the latter part of today. But all the components that you need are in there. And Hayden, if you missed it, I did send down the spare pack there with a few spare parts, should somebody come afoul or something whilst they're actually building it. The kit itself, it's broken down. There's a sheet of paper in there. On the back of that sheet is the bill of materials for the kit, and you can just identify them there as we run around. The first bag here contains a sub bag 1A, in which you've got all the diodes and inductors. The main bag contains all the capacitors and resistors that you need. The static sensitive devices are sitting in this static sensitive bag, and in there you'll find the 2 inline packages for the octal buffer and the receiver chip. There are 4 FETs, the BS170s. There's the SI5351 and also the Arduino Nanos that's sitting in there. Now, the Arduino Nanos have been opened because I pre-installed the software onto those. So that should save you a little bit of time, hopefully, as you work through. But full details there. The low-pass filter kit sits up here, where you have the, and you'll see more, whoops, jumped ahead too much. You'll see more of that on a couple more slides coming up. The construction manual that I originally wrote for the Cowtown project has been augmented and added to as we've done this project a few times. And I specifically updated to 1.6.1, which incorporates all the things that are unique to the Reast build, and also incorporates a lot of the learnings that that we had on the way through. Look, I think it's a pretty good manual. There's a lot of detail in there. But for those that are very experienced kit builders, please forgive my verbosity in there. It's really designed for someone who's perhaps building a kit for the very first time. There's a lot of detail about what to do, and I'm sure you'll either appreciate it or get very frustrated by it. But either which way, you should be able to have no problems building the kit with the details that are there. The manual itself is, so it's 42 pages long. There's a lot of detail there, but you can really break it down. Look, there's a preamble where we talk about the setup, the equipment you need, the bill of materials. There's the circuit diagrams for the ADX itself, some construction tips as to how best to go about it. The instructions are really from page 12 to 26. That's where you'll find all the details that are there. Then have a section on settings and calibrating it, how to use it, how to connect it up to your computer in WSJTX. There's a section there where I've included some information on tuning and optimizing it, and a few bits of miscellaneous information sitting down the bottom. So as I said, 42 pages may sound a lot, but there's a lot of good information in there, and I hope you'll find it reasonably logically organized. The firmware, as I said, it's a discussion about that on page 29 in the manual. The latest version is ADX CAT, which means the version with CAT control 1.6, heptad, meaning that it's got the 7 bands, and this is version 2.1. So there's been a couple of cleanups, a couple of improvements added since we first did it, but that's the version I use in my own ADX, and that's the one that I've put into the nanos that I sent down with the project. Now, if you do want to, if you're that way inclined, you like to play with code, do something different, improve it, by all means, go ahead and do so. The source code for that is available from the Cowtown ADX project GitHub site. You can see it here. There's the code there, and you just have to load it using the Arduino IDE. Just the nanos that were sent down used the old bootloader, so you would need to configure the old bootloader in order to successfully upload to the nano. Now, just a few words about the low-pass filters. The original low-pass filter that was used by Barb was the one that was used in the Micro SDX. It's the Mike 0 November Oscar design. Barb's LPF supported both through-hole capacitors, as shown here in the ADX-S LPS that Adam supplied, but also it supports both 805 or 1206 SMDs, which you can see here by simply soldering those to the through holes, just here like that. So, whoops, sorry. The through holes that were in there. Now, we approached this is the way we initially did it, and thank goodness we've moved on from there. I couldn't end up sourcing small enough capacitors in Texas to do this, so I ended up personally manufacturing about 1,300 and something, or placing 1,300 surface mount capacitors onto these boards so that everybody had the low pass filters to do. That was enough to do it once only. And by the time we came around to the second project, Mark Colros, KD5RXT, was stepped up and helped and did the design work to take those boards and actually put them onto a set of 7 boards using surface mount devices, which we got pre-manufactured, and used those very successfully. The only problem that we found was that the production cost using the V-cuts meant that we couldn't use the economy production method that the PCB manufacturers provided. So these ended up being fairly expensive. I think they were about $22, $23 each per board for the last project that we did. So when we approached the Reast project, I decided to redesign that board and use mouse bytes. As you can see here, this is a photograph of the board that you guys have got and the one that's included in your kit. So all you need to do here is break off the individual board, file down any loose edges, if you will, and just wind the toroids, solder them in, and the capacitors are already pre-mounted on there. Now, I mean, the reality is the low-pass filter kit is about 40% of the total cost of the kits that you've been supplied. But they are manufactured surface mount devices. One thing that we discovered with this project we ran here in Sydney, I actually ordered the toroids from China, and much to our disgust, frustration, and anger, we discovered after everybody had built their low-pass filters that the T37-2s that were supplied from China were actually fakes. They weren't the right material. They were just a toroid that had been spray painted red and sold as a T32-2. So we ended up having to rebuy the toroids. We got the genuine micrometal ones from the US, and they're the ones that you have in your kit. So they're not inexpensive toroids, but they're the genuine real deal. So you can certainly trust them on the way through. Said it uses V-cuts, mouse bytes, not V-cuts, which made it cheaper to produce and enabled me to put the kits together for the price that you guys have. Now, just a point, normally the capacitors are all 100 volt rated. It does get difficult at times to source 100 volt rated capacitors in the exact values for the particular project. And that's why, for example, there's a lot of parallel capacitors, and there's one area on the board I'm just looking here. We've got the option of both installing parallel or serial capacitors to arrive at the correct value. But the reality is, in the time that we had, there wasn't time for in this case, GL-PCB to bring in the additional capacitors. So 3 of the capacitors are on the LPS are actually 50 volt rated, and that's this capacitor here, which is the 130 picofarad capacitor on the 40 meter board, and the 2000 picofarad or 2 nanofarad picofarads on the 2 nanofarads on the 80 meter board. Now that won't be a problem because you shouldn't normally be exceeding 5 watts on those bands. 5 watts, I think from memory, is 45 volts peak to peak, so you have no problems there. But the design actually has this protection diode in there, and that'll conduct and prevent any voltage going above 50 volts. So I don't believe this will provide any problem whatsoever. In fact, we used one 50 volt capacitor on the Manly Group's build, and that's performing beautifully on the way through. So there's no problems there. And you may see there's a couple of spots here, for example, where you may think there would be a capacitor. There are no missing capacitors. We just haven't taken advantage of the capacitor lay down options to get the required voltage. And big thank you for Mark for creating those fundamental designs in the first place. Now, I mean, the bandpass filters are probably one of the areas that are constantly undergoing the most change as we've gone through. I considered modifying the ADX for this project and use the same system that the ADX minis use, because when you look at the low pass filter, L3 and this C7 capacitor over here are common on every one of the filters. So unlike the ADXs, which use all 3, let me just find they actually use three inductors. The Micro Mini just uses 2 inductors, having placed the 3rd inductor and the common capacitor on the motherboard. Now, unfortunately, I didn't have time to do that ahead of your build. That may be a future development, but at least this way, they're common across all of the ADXs if you need to swap them around, or in my case, keep using the ones that I have. By the way, these low-pass filters are generally, particularly the ones that have been pre-manufactured, they are not inexpensive. So I think the kit of 7 that you had should serve you fairly well. I'm also looking at potentially changing the main board in future to include some mods. There's a resistor and diode modification that's covered in the instruction manual that you have. But also, I'm very interested in the heatsink system that QRP labs use for the BS170s. They actually take the BS170s, they fold them over and press them down against an area of the PCB. So the whole ground plane is exposed here, and the transistors sit against that, and it dissipates heat, uses the ground plane on the PCB as a heatsink, which is I think it's a great idea, and it won't be too hard to modify the ADX at some point in time to actually start doing that. So I just want to share with you a few of the lessons learnt during the previous builds that we've gone through. I think at this stage I've been involved in building about 85 of them through the two projects, and then you guys have got about another just under 30 coming through. So there's a fair bit of experience now with people building them to share. The first is that if people who take their time and follow the sequence in the manual and don't jump ahead or and just follow it step by step, have the greatest success. Virtually no one who has not jumped ahead hasn't had a problem with the build, and it's a successful operation once it's completed. I've had 2 or 3 people use too much heat when they've been soldering the kits together. That's usually resulted in track damage and also some component damage. So make sure your soldering iron is at the right temperature, and don't hold it on too long. I like to use what I call my 3-second technique. Having tinned the soldering iron, apply the solder, wait for a second, add the solder, melt it, wait for a second for it to flow, and then remove. And then just try and spread the thermal load on the components as you work around. Watch for static damage on your SI5351. I've blown a couple up, a couple of people have, and I talk to that in the construction manual. I've not seen any faulty CD2003s or the SN74s. Whilst the CD2003s have been sourced from China, the SN74s that you have together with the BS170s have been sourced from the US. So I'm not expecting any problems whatsoever with those. All the CD2003s I've had have all worked without any problem, and I've used the same source of supply for the Reast kit. I've only had 2 people solder their Arduino Nano directly to the PCB. I strongly discourage it in case you blow the Nano up. And one of the common things that has occurred is people have been doing the power testing and have shorted out a couple of the power lines out of the Nano, destroying the onboard regulator and requiring the Nano to be replaced. That's fairly difficult to do if you've actually gone and directly soldered it to the PCB, hence why in the instruction, in fact, you can just see vaguely down here, it's inserted using header pins into the ADX. Suggest that everybody use the same polarity for the low pass filter headers. If you use the way that's recommended in the board, you have the female header on one side, the male header on the other. Obviously, the LPFs are the opposite of that. That way, you can share the LPFs around one another, or if you have somebody that's managed to tune their LPF beautifully, you can see how that performs in your own device, and you can swap them easily from one build to another. Do take the time to tune your LPF for maximum efficiency, calibrate the ADX VFO, and use the correct power supply. 12 volts, no more than that. I did send some information out in the circular, and there's a range of power supply options that are available. I personally tend to use my 3 LiPos. I actually have a slightly different housing for that, but that's what I tend to use most often, or I plug it directly into a bench supply when it's sitting in the shack. I have one of these, which is a buck converter to drop it down an external supply. You plug that into a car power supply, you drop it down to slightly less than 12 volts. And if you use this particular, the MP1584, it's relatively low noise, and it's quite successful operating the ADX for that. I did put together some support videos which cover the tuning, optimizing the LPFs, and also operating. That's where you'll find them. If you can never remember that, just search for me on YouTube, and that a few other presentations I've done will come up, but you'll certainly be able to find these on the way through. Look, I won't go into a lot of detail here, but it really is important that you do take the time to tune your low pass filter to get the PA efficiency out. The low pass filter, the structure is shown here. The low pass filter at the front end, the notch filter in the middle, and then there's a DC feed filter for the BS170s. Now, the notch filter is the filter that's supposed to have the most impact on the efficiency of the PA. But my own testing and what I point to in the video here is that varying L2 seems to have the most immediate impact on the efficiency and performance of the power amplifier, the Class C amplifier. So that's the way it tends to go. And if you're worrying about changing that, of course, we've tested all of the low pass filters, and I suggest if you do have access to a spectrum analyzer, it's certainly worthwhile doing that just for your own benefit. You can see here that this is just the testing that I did a couple of years ago on the filters that I had. If you're going to feed in, of course, make sure you use an attenuator on the way through into the spectrum analyzer. Now, a number of people wanted to get hold of a Barb-a-Watt kit, and I commend you for doing that. It's a great piece of gear. That's a picture of mine sitting up here, and I use that virtually every time I'm doing anything with QRP gear. Do make sure you get the correct manual. You're looking for version 2.31. I think I point you to the GitHub site here to get that in the piece of paper that's in the kit. There are two versions of the manual. 2.31, which is the one I have, and the one that you guys have got is the 9-volt battery version. Version 3.1 is for the 3-volt battery version. There are a few differences between the two in the build, but fundamentally it's exactly the same device. They perform the same way and operate off the same code, etc. The only tricky bit is just making sure you wind the toroid, the binocular toroid, correctly, and that's covered in detail in the manual. All right, well, I've been chatting now for about 45 minutes, which I think is probably long enough. Here's just a screenshot of my ADX in operation when I was in the US. It works. I mean, I'm not going to suggest for a moment that it's equivalent performance of a QDX or your IC7300 or your Yaesu commercial rig, but for something that you build yourself, have a lot of fun doing, it's a great little radio, and I hope you enjoy it. If you do want to use Whisper, which you can do very easily, make sure your PA is operating efficiently. The Whisper transmission lasts 2 minutes, so if you're running your PA at less than 70% efficiency, those BS170s are going to get very hot and you potentially burn them out. Documentation can be found here, and I sent copies of these slides down to Jason today, so everybody should be able to get a copy of them if they wish. And I just want to finish up sharing the note that Barb sent us after we had done the Countdown project. He was very excited that the whole reason that he designed the project was for clubs to have fun and build these sorts of things. And I'm pleased that a couple of other, I mean, there's a few other clubs in the US that I'm aware of that have also done this. And I hope you get as much fun out of the process as I did. And certainly a big thanks to Barb once again for doing that. All right, that's the end of my presentation. So I hope you're still awake. I'll stop sharing, and maybe we can perhaps go to any questions should anybody have them.
Question. Speak up.
And let me see if I can get my camera back on. There we go.
Oh, thank you, Richard.
Good.
I was going to ask about the heat sinking for the BS170s because having built also a QDX, I went to a lot of trouble with the little heat sinker arrangement, and I wondered what you were going to do with the ADX. So you've answered that question, I think. Yeah,
look, the reality is if you have the ADX tuned properly, you don't need to use a heatsink. I don't use one on mine. I've got all of my low pass filters above 70%, and I always check to make sure that I'm going into a tuned antenna or through an ATU to do it. So you don't need to do that. If you want to develop some sort of mechanical heatsink and add it to it, you can certainly do that. But it's just that I found that the well, first of all, I originally didn't know how to use KiCad, and I'm just in the middle of my next project that I'm doing is this guy here, which is to try and get it to focus on the camera. It's probably not going to work. Which is a Pi Pico SDR receiver, and I had to teach myself to use KiCad to design that board. So now I feel as though I've got the competence to go and make changes to the ADX to do that, because I think that I usually find most people are running their power amplifiers too hot because they haven't taken the time to tune the low pass filter. But that would certainly solve that problem a little bit if it was able to take advantage of effectively, consider the top and the bottom. You've got 100 millimeters by 100 meters twice of ground plane that you could use as a heat sink.
Oh, fantastic! Thank you. Any other questions?
I've stunned them all.
What's the possibility of using the ADX on 160 meters?
I believe it can be. I haven't seen a lot of digital activity down there, but I don't go down there very much. Don't take my word for it, but I have something twiddling around the back of my mind that said that somebody has got it successfully working on 160 meters.
Okay, fine.
Theoretically, I don't see why it shouldn't if you've got the appropriate filter.
Yeah. Okay.
Cool. Are the 1860 650 batteries LiPos or lithium ions?
They're lithium ion. Oh, sorry, no, they're lithium. They're LiPos. I had them. I had them one of these. Try and get it in focus. Yes, I had it in those little black packs that you sort of buy from AliExpress. That's going to give you a little bit more than 12 volts, but by the time there's a protection diode in there, and by the time the voltage gets through to the nano, it's not in a danger zone, and you can successfully use it. I use the same ones for my QDX, my QMX, all of my QRP radios. So it's if you have access to them. In fact, one of the easiest ways to get those cells is to find an old laptop battery pack that's died, pull it apart. You'll generally find that only one or two of the cells has gone crook. The rest of them are still perfectly usable, and then you've got yourself a nice little battery pack that you can use for QRP. By the way, just a question for you guys: was anybody on the John Moyle Field Day on the weekend?
Yes.
Did anybody work VK2MB portable? If you did, this is the photograph in the background here was our John Moyle Field Day spot up in the mountains about 100 kilometres north of Sydney. Tasmania seemed to be very well represented in the participants. So if you look in your log, you saw VK2MB, you may have spoken to myself or one of the other guys from the club, and that's where we were operating from. So that's where the background picture is.
Oh, fantastic. Cool. Cool. Any other questions? I think we're all raring to go.
Well, look, I wish you luck. I do get down to Tasmania from time to time, so if anybody gets stuck with their ADX, please let me know. And you can find my contact details on QRZ, and don't hesitate to send a question, or I'll be happy to help whichever way I can. I hope you enjoyed the project.
Great. And if you're down here on a Wednesday night, please come up to the club.
Yeah, I know where you are. I used to go up to the domain to do some antenna testing with my father when I was a late teenage years. So I'm fairly familiar with where you are.
Only a couple of years ago then.
Oh, you're too kind.
Oh, fantastic.
We've already got the kit. He's not going to give you anything else.
Oh, very good. Fantastic.
We'll be taking some video and photos over the next couple of weeks as well, so we'll share that with you.
Yeah, look, I know that Barb, I was speaking to him a couple of weeks ago and let him know that this was coming up and you guys were doing this. He was very keen to get some photos of the event. So please do that and look forward to seeing how you progress. So good luck.